density of water. We're going to see that if we put different amounts of water in here and measure them, if they come out to be the same or different. That's like the whole goal of this lab. So what we're going to do first is, this is different than doing the density of solids, where volume was kind of a pain in the neck because you had to do length, width, or height, and water displacement. Today, volume's going to be the easy one, because all you have to do when you're measuring a liquid is pour the amount in, and that you're done. So what are we starting with? What's up there on the board? You guys can answer. How much are we starting with? What's the first amount? 25. Good. All right. Give Amol a hua. So, what I'm going to do is, what do I do first though? I already have 25 milliliters. That's going to be my amount, right? But when I'm doing the mass of water, I can't just pour 25 milliliters onto the, even though my wife would laugh because I spill a lot, but I have to do what first? Because if I pour it on the scale, it's not like going to sit on the pan, is it? So what do I have to do? Go ahead, Mom.
You got to pour it in there.
Good. I have to pour it in here, but there's one problem. If I pour it in here, it's going to give me the mass of the cylinder and the water. So what do I have to do first?
You gotta, I don't know.
Okay, go ahead. Go ahead, Mira.
You have to do the volume of displacement?
Not displacement, because that's, we're not finding the volume now. We're finding the mass of the amount of water we're going to do. So how do I only get the mass of the water?
Find the mass of the empty graduated cylinder and...
Good. See how it gets confusing sometimes? So we're going to do the mass of we have to do the mass of the empty cylinder first. So give everybody a hoo-wah because everybody contributed, right? Come on.
Wow.
Louder. Ah, there we go. Come on. All right. Now listen. All right. I'm not... Okay. So now we have to measure how heavy the empty cylinder is. And I'm going to kind of skip a few corners here because I know what it should be about. Okay, so if it's at 40 now, what do I have to do? It went down, so what do I do, everybody?
Move it
Move it
back.
back one. So we're at 30, right?
Yeah.
So we have to go this way a little bit, actually a lot, and try to get this. We have the 0 mark here, and the pointer has to be what, guys, with the 0 mark? It has to be lined up and even, right? So let's see if this evens out now. Come on, man. Let's go. All right. All right, that's about right. Maybe a little bit less. So that's good. We're going to write down for that 37.7. All right? So up on the board, we're going to have the same thing up there in a minute, so I'll kind of go along with it when we actually show the video. So I'm going to write 37.7 here, and then I'm just going to pour the amount of water in here, and then we're going to put it back on the scale. What are we going to do with those two numbers, everybody? What did I just do? I put way too much in. I spilled just like I do at home. So here we go. Good. So that's 25. Now we're going to put that back on the scale and get this real fast. It goes down. So what do I do, everybody? Move it back one. And we're going to go like this. That's too much. Go back a little bit. So let's see. It should be somewhere around here. More. That looks good, right? So we have 60. We didn't have any hundreds here, right?
Yeah.
And now we have 1, and it's between 1.4 and 1.5. And if it's between those two numbers, we'll always go to the larger number, so it'll be 1.5. So my answer is 61.5 grams. So we subtract these two. And if you can get this, fine. If not, don't worry about it. But we're going to do this real fast. So that would be 3. And it comes out to 23.8 grams. Now, we're going to take what? How do we find the density? What are we supposed to do? What's the equation?
Mass divided by volume.
Mass divided by volume. Very good. Okay. So what we're gonna do is take the mass, it's 23.7 grams, and divide it by 25. Now, some people like, oh, I have to do the larger number and divide by the smaller, but is that true? Do we always have to do that? No. So we're gonna take 23.7 divided by 25, and your answer is gonna come out to be about 0.9 grams per centimeters cubed when you round it off, okay? So 0.9 grams per centimeter cubed is our answer. We're going to see with this rest of this lab if they all turn out to be pretty close to this, because in a minute we're going to make a prediction about whether you think all the densities are going to be the same or do you think they're all going to be different, okay? And that's how we find the density of a certain amount of water, which is what we just did. So sounding off. All right, you can stop it.